Bright Duty. Every student matters.
After knowing so much about atoms, it became of great importance to understand that what is the atomic mass or what is the weight of an atom. Now, there were a number of suggestions which were given by many scientists and chemists during those days. One ruling came that let us take oxygen atom as the standard. Now, why oxygen atom? Because oxygen is such an element which reacts with almost all other elements, whether it is a metal or a non-metal, to form oxides. So they started using oxygen as the unit mass, standard mass, with in comparison to which the mass of that particular atom was taken into consideration. But later on that was discarded because oxygen itself was a heavy atom. Then came into consideration taking hydrogen, because hydrogen, we know that when we look into the periodic table, hydrogen is the first and the lightest element of all the different elements that we have. But even that was discarded. Later on, in 1961, the scientists throughout the world came to a common conscience that they accepted carbon-12 as the standard unit of atomic mass. Now, what is carbon-12? Carbon-12 is an isotope of carbon. Carbon exists in three isotopes: carbon-12, carbon-13 and carbon-14, which you are going to learn in the coming chapter. Now, they took carbon-12 into consideration, and taking carbon-12, one unit of carbon-12 as the standard unit, other atoms of different elements were compared. Now, what is the atomic mass? Thus, in comparison to carbon-12, the atomic mass would be one atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon-12. Now, what is carbon-12? Carbon-12 is, as I told you, it is an isotope. Now, for that, let me give you an example. Now, that example can be, suppose you go to a market and you want to buy a watermelon, but you do not want to take the entire lot of the watermelon. You just want 2 slices of watermelon, a small portion. And the person who is there, he doesn't have a weight, a standard weight, with respect to which he would weigh it for you. So what is the other option that the shopkeeper or the fruit seller can do? What he can do is, the entire watermelon, he can divide it into 12 equal parts. Okay, so what does he do? He divides 2 parts, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, okay, and 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and thus we have the 12 sections. So what the fruit seller can do, divide the entire watermelon into 12 equal parts, and then from there he can scoop out one section of it. That means he has a standard one section. Now, that one section of watermelon which is present is the unit mass. Why unit mass? Because with respect to that, he can sell the watermelon. That means now you can ask that please give me 2 slices of it. So what he would do, he would take this as the standard unit, and in comparison to this particular unit, he is going to make a comparison. He is going to give you 1, so he is going to give 2 slices of equal size, which he is going to compare with the standard unit. So this is exactly what they did with atomic masses. They took 1/12 part of carbon-12 isotope. So carbon-12 isotope was divided into 12 equal parts, and they took only one section as one unit. So 1/12 of carbon-12 isotope was equal to 1 unit, and which they compared and found it to be equal to hydrogen. And thus came the concept of atomic mass, which was universally accepted by all the scientists and chemists. So let me define what is atomic mass. One atomic mass unit is a mass unit which is equal to exactly 1/12 the mass of one atom of carbon-12. So if you take one atom of carbon, 1/12 the mass of carbon-12, then 1 atomic mass is equal to that. So this is what it means to have atomic mass. I hope this point is clear to you and you know how the comparison has been made. Now let us, on the basis of this, define what is atomic mass unit. So I don't need to redefine it. You already know what is it. 1 atomic mass unit is a mass unit which is equal to exactly 1/12 the mass of one atom of carbon-12. Next, why is it not possible to see an atom with naked eyes? Now, why do you think so? Because the size of an atom is very, very minute and it is almost 1 nanometer, which is of the accordance to 10 to the power minus 9 meters. So you can imagine that how small and how minute is the size of an atom, which becomes very difficult for us to see through our naked eyes. That's why we cannot see an atom with our naked eyes.